Okay, so this is video number 2 about the pre-calculus exam brief or debrief. This is a multiple choice portion. Again, let's follow directions. It says use available room for scratch paper. You get no scratch paper on the SAT or the AP test. So we've constructed this exam similar to that, where you have a lot of room over here on the side and you can do scratch paper if you want. The directions here say circle the letter, bold, italicized, underlined. So if this is our solution, we would circle A. Circle the letter of the correct choice. Simplify all numerical answers unless otherwise indicated. Approximations must be accurate to the nearest thousandth. 1 point, no partial credit. Some problems, such as the ones below, are designated calc. And these are designed to be solved with the graphing calculator. I have my emulator over here to the right. Calculator is permitted for the entire exam, but you should know that using a calculator on problems that are not designated calculator problems may take too much time. But we'll look at it as we go through the test. Okay, number 1, find all solutions to this cubic. There are 2 ways of doing this. My preferred method is to set the equation equal to 0. So we have 0 is equal to x cubed minus 3x plus 3 over x minus pi. And then imagine a function, we can call it y1 if you want, as it's this cubic. And then what we're looking for is the zeros of this function, right, where the function is equal to 0. So that's probably the best way to do these things. I've got my calculator in classic mode here. So my cubic is just in caret, x cubed minus 3x plus 3 over x, and then minus pi. There's my pi button right there. Okay, so now we look at the graph of this in the standard window and hope that Zoom 6 is my standard, Zoom 6. And sure enough, we see a couple of zeros. These would be the solutions to this equation, assuming there are no others. We look at the choices, and no choice has more than 2 solutions, so we suspect that's it. Let me zoom in a little bit, zoom to enter. And we see one solution's between 0 and 1, and the other one looks like it's just shy of 2. So let's chase those down. Second trace. 0 utility is number 2. For a left bound, I'll type in 0, enter. And then for a right bound, I'll type in 1 and enter. And you notice the 2 little arrows appear on the screen there with some vertical lines. One vertical line happens to be right along the y-axis. But then it says to guess, and we always just choose the last one as the guess, and there's our 0, which is 0.6279-ish. Right? So x is about 0.627909. There's some other digits after that. The only one that is similar to that is this one right here. Okay. So it does say round to the nearest thousandth. This would kick the 7 to an 8. Okay. And just as a double check, let's chase down the larger of the 2 zeros. Second trace 0, somewhere between 1 and 2 it appears. 1, enter, 2, enter, enter. And we get 1.955. So sure enough, that is the correct solution. And we would circle the letter B. Okay, question number 2. Find all solutions to this. Well, again, we'll do the same thing. We can either move the natural log to the right and have x minus natural log of x, or if we wanted to, we could move the x this way and have natural log of x minus x is equal to 0. Both of these will work. I like this approach a little bit more than this. This is a little ambiguous. Am I trying to take the log of x minus x? Is that what you're doing, Bosque? No, because that's actually undefined, right? You can't find the log of 0. This makes it a little bit clearer. You've got x, and then you're subtracting off the log of x. So y equals clear. We'll put the first one in, x less log of x. We're using the natural log here. Zoom 6, standard window. You see a rather interesting graph. It appears as though it's only defined for positive x values, which makes sense, right? Because the log requires x to be bigger than 0. So if we tweak our window here just a little bit and make it so that the smallest x is 0, and maybe the biggest x will just go up to 5 or so, and look and see what's happening. Sure enough, we see this graph that appears to go asymptotic to the positive y-axis. Maybe we can see that even more clearly if we make this one. I'm just sort of playing with the window here. You don't have to do any of this, of course. And we'll make that 20 and see if we can. Yeah, it's sort of hard to tell, but I bet you, if I were to look at a graph of this, it's going to go like this. And maybe we can just, for the heck of it, ask what happens if x is 0.0001, and then the y comes out to be 9. So it does go up. And if x is 0.0000000001, then y is all the way up at 25. So sure enough, this approaches the positive y-axis asymptotically back to our standard window. There are no solutions to this equation. So we would go no solutions. There are no zeros. Now, by the way, if you just look at that picture, let me throw the other equation in here where I have the natural log of x first, close that off, and then subtract x. You would see, this is a red one, obviously. You just see the mirror image of it. Still no zeros. So it doesn't matter which one you use. This is the red graph, and the top one would be the blue graph. Okay, number 3, find all solutions. We have an exponential expression, 3 to the x, and a quartic, I'll subtract the x to the 4th, equals 0. Right, so I'm just moving this term over there. And we'll dump that in to our equation editor. So 3, again, I'll use the caret, 3 to the x, and then less x to the 4th. Standard window, zoom 6. I see 3 zeros apparently. The only choice that has 3 zeros is E, but we might want to just double check and make sure those are the right ones. If we look at this leftmost on the graph, it's near -1, second calc 0. So -1 and 0, I would think. -1 is the left bound, 0 is the right bound, and then guess. Sure enough, 0.8002. The next one's between 2 and 3. Second trace, 0. Left bound, right bound, guess. Whoops, no sign change. Let's go back and look at the picture again. What did I do? It's not between 2 and 3, it's between 1 and 2. Haha. Notice when I entered between 2 and 3, there was no sign change. The graph was negative the entire time. So I did not, my little zero utility did not find a 0, but if I do this correctly, I would get between 1 and 2, and then I'm good. 1.517 rounding, and we'll save the last one for somebody else to do. Okay, calc number 4. Given this quadratic, how many zeros does the function have? How many real solutions are there to this equation? How many x-intercepts are there to the graph? By the way, these are all the same question. That's sort of an important idea, that finding x-intercepts, finding real solutions to an equation where a function is equal to 0, or finding what are called the zeros. Some textbooks actually use the word roots, finding the roots to a function. They all mean the same thing. So let's see if we can chase this guy down. And we've got 5x squared less x and less 4,774. And here we are in the standard window, and we see absolutely nothing. Okay, so what's going on here? We do know that this is a parabola. we have 5x squares, right, less x less 4774. And because the leading coefficient here is positive, we know this parabola opens up. So I suppose there's a number of different scenarios here. You could have the parabola above the x-axis like that with no zeros. You could have it so the vertex is actually right on the x-axis like that, where you might have but 1 0. Or you might have the parabola below the x-axis like that, where there would be 2 zeros. And right now we don't see any. So maybe our window's too small. We can try zooming out, see if that helps. Zoom 3, enter is zoom out. And sure enough, I do see parts of the graph hitting the axis. Where might that be? If we look at the window when we zoomed out, it went from a min of -10 to a min of -40, and a max of +10 to a max of +40. So this was a zoom factor of 4 times further away. The scale, unfortunately, didn't change. It was still 1. Let's make that 10 and look at the picture. Okay, so 10, 20, 30, 40. That one to the right looks like it's between 30 and 40, and so we can chase that down. Second trace 0, somewhere between 30 and 40. And yes, and we get a 0 of 31. Okay, so that is one solution to this equation. X would be 31. Here's our equation that we're trying to solve again, right? So we know x is equal to 31. And by the way, that means there is a factor, of course, of x minus 31. And maybe there's some other factor that we could come up with. It looks on the negative side, somewhere around -30. It's sort of hard to tell. Let me go between -40 and -20 and see if we can pull it up. Left bound -40, it's at the edge of the window there. Right bound -20, and guess, and it says -30.8, -30.8. So x plus 30.8. So that would be the other. Well, actually, that doesn't make sense because x times x is not going to give us 5x. Maybe if we put a 5 in there, that might give it to us. We would have to play with this a little bit to actually get the factors. My gut instinct is there's a 5 here and an x minus 30.8. We can play with that a little bit more later. But for this problem, it just says how many solutions are there? And the answer is there are 2 solutions. And by the way, if this equation looked familiar, it was this problem that you had on your little quiz on series. This was probably the hardest question on the quiz. And the question was, in this series, the partial sum, if you add up a number of terms, you get 2387. How many terms must be added? And if you remember doing this one, you needed to first find the nth term, a sub n, not too hard, 5n less 3. And so the series looks like this. And they gave us the sum is 2387. And the question was, how many terms does it take to get there? And so you probably, if you got this one right, you probably use the summation formula, right? S sub n. It's going to be n over 2. We don't know n. We do know the first term is 2. And we know the last term is this 5n minus 3. And in fact, we know what the sum is. It's 2387. So if you take this equation and solve that for n, well, let's clean it up a little bit. Multiply both sides by 2. And we get n times 2 plus 5n minus 3. I suppose I should clean that up as 5n minus 1. And this is what, 4, carry 1, 7, carry 1, 7, 4. Son of a gun, there's that 4774 again. And cleaning this up, 5n squared less n less 4774 is equal to 0. So that was the equation you needed to solve on the quiz to figure out what n was. And we've already seen that n was equal to 31. You had to add up 31 terms to get that sum. You probably did it on your calculator. Okay. Number 5, the circle with center and radius can be written in graphing form. That's nice. You should know the graphing form. In trig, by the way, we spend almost the entire semester talking about one particular circle. The graphing form for all circles is x minus h, right? Quantity squared, plus y minus k, quantity squared, is r squared. And here they tell us we have a center and a radius, and if each binomial is expanded, like terms are collected. So that's not terribly hard. We're going to take x plus 2. We're going to expand that. We're going to take y minus 5 and expand that. And then collect like terms. Notice the right side of all these choices is 0. So the 9 is going to have to come to the left, where we have x squared plus 4x plus 4 plus y squared minus 10y plus 25 less 9 is 0. And as an aside, in pre-calculus, if you cannot go from taking this binomial as a square and almost immediately writing this down, you've got some practice to do. If you're still at the stage where you've got to go y minus 5 times y minus 5 and actually show the little foiling out and collecting like terms, you're going to be terribly far behind. So get on the stick, get some practice squaring binomials quickly and easily. Okay, so now that I've given you a little bit of motivation, let's go and clean this up. It says collect like terms. All the choices have the squares first, so we'll do that. The x squared and then the y squared. Typically we do this in alphabetical order. So 4x and then minus 10y, and we just have to get the constant. So we have 4 and 25 is 29, less 9 is 20. Okay, so that's the answer. And there's the choice. Which one we got? It's choice A, I think, right? Yeah, 4x minus 10y. Okay, good. Number 6. And let me just check. Okay, we're at 17 minutes right now. Let me go ahead and stop this one. Again, I wanted to try to keep these at 15 minutes or so. So we'll stop this and then pick this up on another video.